Welcome students. Physics Icse 10 Standard Chapter 4 Refraction of Light at Plane Surface. So what is refraction of light? The change in direction of the path of light when it passes from one transparent medium to another transparent medium is called refraction. We will see some images from the internet so that we can understand the refraction. See here, the incident light is here. This is the normal and the refracted light is here. So there is a change in the angle. The angle over here is changed here. That change is called the refraction. So what is refraction of light? Refraction of the light, the change in the direction of the path of light when it passes from one transparent medium to another transparent medium is called refraction. So we'll try to understand something about this. Light travels with different speeds in different medium. It travels faster in air than in water or in glass. The speed of light in air, the speed of light is 3 lakh kilometers per second in air, 2.25 lakh kilometers per second in water, 2 lakh kilometers per second in glass. A medium is said to be optical denser if light slowed down in it, and it is said to be rarer if light speeds up in it. Now, so rarer medium is the air, and comparatively denser medium is water, and still denser medium is glass. We say that water and glass are optically denser than air, or in other words, air is optically rarer than the water and glass. Glass is optically denser than water, or water is optically rarer than glass. Refraction of light. Change of medium causes partial reflection and refraction at the boundary of two media. In a homogeneous transparent medium, light travels in a straight line. But when a ray of light traveling in one transparent medium strikes obliquely at the surface of another transparent medium, a part of light returns back into the same medium obeying the law of reflection, which is called reflected light. The remaining part of the light passes into the other medium and travels in a direction different from its initial direction and is called refracted light. Thus, at the boundary separating the two medium, light suffers a partial reflection and partial refraction. The change in direction of the path of light when it passes from one transparent medium to another transparent medium is called the refraction of light. The refraction of light is essentially a surface phenomenon. When light traveling in one medium falls on the surface, a small part of light is reflected back in the same medium. Okay. Next, there is partial reflection and refraction at the boundary or the surface. So we have few images from internet which shows the refraction of light. So we will take this image to understand. See, incident ray is coming here. So this is the normal, and this is the rarer medium, and this is the denser medium. So what happens when the light hits the surface? It gets refracted. That is change in the direction. And what happens if it is from the rarer medium to the denser medium? It goes towards the normal. And if it is denser to rarer, it goes away from the normal. That's why I picked this image for you. Now, what is optical density? See, optical density has no relation with the density of the medium. Optical density of a medium depends on the speed of light in the medium, while the density of the medium depends on its intermolecular separation. Change of medium causes the partial reflection and refraction at the boundary of two media. The refraction of light is essentially a surface phenomenon. What is the cause of refraction? When a ray of light passes from one medium to another medium, its direction changes because of change in speed of light from one medium to another. That is the reason. This can be a give reason question. Now we have laws of refraction. So what are the laws of refraction? The incident ray, the refracted ray, at the point of incidence all lie in the same plane. The ratio of the sine angle of incidence to the sine angle of refraction is a constant for the pair of given media. This constant is called refractive index of the second medium with respect to the first medium, that is sin I by sin R. This law is also referred to as Snell's law. Now refractive index. The refractive index of the second medium with respect to the first medium is defined as the ratio of the sine angles of the incidence in the first medium to the sine angle of the refraction in the second medium. So this does not have any unit. Refractive index is a constant. So it does not have unit because they are ratio of two similar quantities. So now absolute refractive index. So absolute refractive index of a medium is defined as the ratio of the speed of light in vacuum to the speed of light in that medium. So now we have a condition for no change in direction when the refraction can be 0. So when the change in angle can be 0. So the two reasons for that is when the angle of incidence at the boundary of two media is 0, or when the refractive index of the medium 2 is same as the medium 1. When at these two conditions, then the refraction can be 0 or the change in direction can be 0. Now we have the factors which now we have factors like change in speed, direction, wavelength of light due to refraction. Due to change in speed of light in passing from one medium to another, the direction of ray of light changes, except if the incident angle is equal to 0. When a ray of light passes from a rarer to a denser medium, the speed of light decreases. So what happens? Rarer to denser medium, the speed of light decreases. If it passes from a denser to rarer, the speed of light increases. Since the frequency of light depends on the source of light, so it does not change on refraction. In refraction of light from one medium to another medium, due to change in the speed of light, the wavelength of light also changes because its frequency remains unchanged. Now we have three factors which affect the refractive index of the medium. So what is that? So first thing is nature of the medium or optical density. Second one is physical conditions such as temperature. And third one is the color or wavelength of the light. So we will see how it affects. Nature of the medium. Smaller the speed of light in a medium relative to air, higher is the refractive index of that medium. So how the temperature plays the role, we will see. With increase in temperature, the speed of the light in the medium increases, so the refractive index of the medium decreases. Now with respect to wavelength or the color. The speed of light of all color is same in air, but in any other transparent medium, the speed of light is different from different colors. So in a medium, red light travels faster than violet light. Therefore, the refractive index of the medium is more for violet light and less for red light. The wavelength of red light is more than of violet light. So refractive index of the medium increases with the decrease in wavelength. So this is the relationship between these three. Next is lateral displacement. So how do we define lateral displacement? Lateral displacement is a phenomenon seen when light travels through one medium to another. It is perpendicular distance between the incident ray and the emergent ray. Its unit is meter because it is a measure and we measure the distance, so the unit is meter. And this lateral displacement depends on three factors. What are they? Thickness of the glass block, angle of incidence, thickness of the glass block, angle of incidence, and refractive index of the glass. We will try to understand how. The lateral displacement increases with increase in thickness of the medium, increases in the angle of incidence, increases in the refractive index. Since refractive index increases with the decrease in wavelength of light, So the lateral displacement increases with the decrease in wavelength of the light.